All right, I am excited because this is the culmination of everything that we've been working towards, being able to graph a trig function given amplitude, period, phase shift, and vertical shift, and understanding where those things are. So, if you look in our example here, we have A representing our amplitude, B showing us how we can get our period. It's not the same thing, keep that in mind. Phase shift represented by our H, and vertical shift represented by our K. So let's jump right into example 3 and see if we could successfully graph these with all of this information. Now, first things first is we have to gather all of our information. So first, we're going to find our amplitude. Our amplitude, as we know, is going to be the absolute value of A. So our amplitude, as we know, is going to equal the absolute value of A. So our amplitude is going to equal 3. Our period is going to be equal to 2 pi over the absolute value of B. So our period in this case is going to be equal to 2 pi divided by 2 over 3. Now that might look complicated, but let's simplify that really quick. We can easily do that by just saying 2 divided by and then divided by again. And now down here we're going to say 2 over 3 and we're going to find a fraction. Now as we can see, it doesn't even need to be converted into a fraction because it's just a whole number 3. Now notice I did not say 2 pi because if I were to put pi, it's a weird decimal. We can just add that in later. If we eliminate pi, it'll just be 3 and then we can throw pi in on the end. So our period is going to be equal to 3 pi. Not too bad. So now we're going to use our phase shift. Now our phase shift is represented by our H value. Now remember, it's the opposite of whatever's going on. So we're going to say it's going to be going to the right pi units. Or we could also say right pi radians, which radians in this case is our unit in which we are using. The vertical shift is going to be whatever our K value is. We can see our K represented by 4, so that just means that our vertical shift is going to be going up by 4. Now, if our graph went up by 4, that means that our midline is going to be at 4, specifically y equals 4. So now the fun part. Let's graph it. Let's use everything that we know about these functions to be able to graph what it looks like. First things first, we need to put our midline. Now my graph is going to be a little bit tall, being that my midline is at 4, so I extend my graph a little bit. Next thing is I want to put in my maximum and minimum lines. That is going to be determined by my amplitude, which is 3, so I'm going to go 3 above and 3 below. Alright, so I'm striving to be as fair as possible with my markings here, so I think I did a pretty good job. Now I want to know, where does my graph start? That is going to be determined by my phase shift. So I need to start at pi, because it went to the right pi radians. We're going to say this is pi. Now my period being 3 pi, that means it's going to take 3 pi radians for the full cycle to complete. So we're going to start at pi, but we're going to go 3 pi to the right, which means we're going to end up at 4 pi. Now what we need to do is we need to divide our sections into 4 equal parts, as so, and we need to label it. Now the best way to do this is take 3 pi, which is our full period, and divide that into 4 and see what we get, and then add it to each section. Now 3 pi divided by 4 is just 3 pi over 4. Now we can easily find out the next and the next and the next by just taking our pi, adding 3 pi over 4, adding 3 pi over 4, adding 3 pi over 4. Looking at decimals, 1 or 1 pi plus 3 pi over 4 equals 7 pi over 4. Another one, we get 5 pi over 2, and one more. We get 13 pi over 4. Now, I know that those don't mean a lot to you, but at least you're able to find them rather easily. Alright, now the hard part is done and we can just get to graphing. We have all the information necessary to just throw in our graph. If we remember correctly, our sine function is going to start at the midline. Then it's going to go up to the highest value and then go down back to the midline and then go down to the lowest value and then go back up to the midline. Now we're just going to connect it with curved lines. Curve, 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 and curve. And we have our sine function. Now remember, this is periodic, so it's going to keep on going like that in the positive direction forever and then the negative direction forever. So we could add on to it, but that is fine for right now. For the guided practice, I was really hoping that we're going to have a tangent example. That way we get a little bit more practice with tangent, but cosine is fine as well. Now, I implore you to pause the video and try this out for yourself. In the other ones, there has been some curveballs that may have thrown you off a bit, but in this one, there is no curveballs. Just try your best and take some time and see if you can get it. Good job on pausing the video. Let's figure this out together. First things first, we're going to find our amplitude, which our amplitude is the absolute value of our A. So in this case, our amplitude is going to equal 2. Our period is going to be 2 pi over the absolute value of our B. So our period is going to be 2 pi divided by 1/2. Now, if we throw that into Desmos, we will find out that our period is actually 4 pi. Our phase shift is represented by our plus pi over 2 in the inside of the parentheses. That means that we are going to go to the left pi over 2 units, or in this case, radians. Vertical shift is represented by our minus 2, which means that we're going to be going down 2 units, which means our midline is going to start at -2. So we would say y equals -2. We have everything necessary to graph. First things first is we're going to graph our midline, which in this case is at y equals -2. So let's do that. Now our amplitude tells us where the top and the bottom are going to be. And in this case, our amplitude is 2. So we're going to go 2 above and 2 below. Now we need to see, where does this start? In this case, our phase shift was left pi over 2 radians, which means we're going to start at -pi over 2. Now where do we end, or end? Well, that's based on our period. It's going to be 4 pi. So if we take -pi over 2 plus 4 pi, we should be able to find out where we would end our first cycle. Another way of saying that is 4 minus 1/2. In this case, that's going to be 7 pi over 2. That's where we're going to end our cycle. We'll say that this is 7 pi over 2. Now we still need to divide this up into 4 equal parts, so let's do that. Again, now the easiest way to identify what each of these marks are is to take our full period, which is 4 pi, divide that by 4, which I don't even have to do in Desmos, is just pi, and we're going to add that to each of the marks, starting with our starting mark, and we'll get the next line over, next line over. So first we have 4 pi, and we're going to divide that by 4, and that's going to equal pi. So that's the thing that we're going to add to each of our marks. This will bring here to pi over 2, the positive side of it. The next one will be 3 pi over 2. The next one will be 5 pi over 2. And just to make sure, if we add pi to 5 pi over 2, we will get to 7 pi over 2. Now we have everything that we need to graph our trig function. If we remember, our trig function starts at the uppermost point, and then it's going to go down to the midline, and then it's going to go down to our bottom line, back up to the midline, and then we have to go back up to the uppermost point. Now, my favorite part to the completion of the graph is just connecting everything with curved lines. Curve, 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 and curve. Now, it may be that I am recording this ridiculously late, but this is a beautiful cosine graph.